So, good evening, everybody, and welcome to the LoopQ Prize Award event. Many of you maybe know that it should have been an live event with in-person presence. Unfortunately, due to the pandemic situation, we are once again forced to uh, choose a digital version for this event. But it will be very interesting as well. So, just to introduce our special event today, I would like to welcome Lisa Anuncio, which is a Customer Success Manager at Loop AI Group. Welcome, Lisa.
Hi everybody, and I welcome you cordially to this award event on behalf of the Loop AI Group staff. So big thanks to all the Loop Q Prize team. Initially, as Luca just said, we thought we would combine an in-person party to a streaming party, but when so many people got COVID in our offices, we moved the party online straight away. Anyway, we are so happy to host this event, first and foremost as an online party, as there are so many competitors from across Africa and Europe who are joining us today. So dear data science students, thank you for joining the competition and for being with us today. We are living a very exciting moment of the development of artificial intelligence, and you probably have heard about the so-called sentient AI hiring itself a lawyer. But in reality, AI boosts medicine, agriculture, and as we at Loop AI see every day, it significantly changes customer satisfaction and operations for the better in insurance companies and bank offices. So the international students have been busy working on two real-life AI challenges. One is focused on speech and motion recognition to understand the feelings of a speaker, while the other aims to improve agriculture, solving a crop yield prediction problem. So for us, AI is not something hyped or another new technology fable, but it's a very powerful tool for genuinely improve life here on Earth for so many people and in so many walks of life. So we have been thrilled to see this AI competition grow first from Italy to an European-wide audience. And this year's third edition embraced also the African university students, and we can see so much AI talents from both continents. So congratulations and thanks again to all participants for getting interested, registered, and for joining us at the LoopQ Prize competition. We wish you all the well-deserved success that you will surely get in your AI endeavors. So thank you, and I pass the ball back to Luca.
Thank you, Lisa. You said something very important. We started from Italy, then we went to Europe, and now Africa is included in the LibQ Prize award event. As we told, it's really a pity we don't have the choice to meet together to talk about AI, to discuss about AI, to share ideas and thoughts about these arguments. But we exploit the technology at its best to ask Patrick Ilen, LoopQ Prize judging panel member and chief AI advisor at Loop AI Group and VP at Unifor, to help us to understand what's coming in the future of AI. Patrick, welcome.
Thank you, Luca. It's great to be here with you today. And I'd like to congratulate everyone who participated in this. We certainly saw a lot of great entries and people worked very hard. And it's certainly an exciting time to be working in AI. And there's always new things to learn. And I think we even learned a lot just from the people who submitted things for the prize. And so it's just a wonderful time to be doing things in AI, and very exciting. Obviously, there are a lot of things in the news right now about AI and where we are and where we're going, things that people have accomplished. And so I decided to name this talk, AI, Are We There Yet? as a kid might say, in the back of the car, because it seems like it's been a very long journey. And, people are eager to think if we're any closer to the goal that, we're all going towards of having an AI that is maybe something like you see in science fiction, something that seems to think for itself and have a kind of intelligence that is similar to a human intelligence. And if you were to talk to some people, for example, Nando de Freitas at Google tweeted recently that he thinks all we really need is more data, and we're on our way to that path. And so many people are asking me all the time, do I think that's true? Is it just a matter of more data that we need? Another thing that, of course, has been in the news recently was Google developed this dialogue system called Lambda. And one of their engineers, tweeted out some conversations that he had with Lambda and said, I think we could say that this thing is sentient, or I don't think that we can't say that it's not sentient. How do we know that this is not already a thinking machine? And it seems to have, some kind of self-awareness and all of the qualities that, we normally would infer when we are, trying to assess if something is sentient or conscious or not. And so, this is a thing I think would be sort of interesting to talk about and to ask ourselves is what does sentience mean? What is consciousness? If the goal is an AI that is conscious or that has an intelligence that is, kind of self-perpetuating in the way that human intelligence is, how will we know when that happens? Now, this is a question that philosophers have been asking themselves and debating about for centuries. What is consciousness? What does it mean to be alive and to be a self and all that type of thing? So I'm going to tell you in a little bit my opinion about how we will know when we have actually created a sentient AI or an intelligence that is on par with a human intelligence. I frankly think it will be pretty easy to spot when it happens, and I'll let you know how we'll know when we get there. But first, I think we should just explore this whole idea of consciousness briefly. I mean, it's a big topic, but there are a few sort of basic qualities that we always associate with consciousness, and one of them is what I just said, sort of self-awareness. This idea that I am here and I exist in the world and I can do things and I have agency. But that leads us to something that is even a little bit more deep, which is this idea of intentionality, right? We all have intentions, which means that I can sort of look at the world and I can produce my own plans for what I want to do in the world. Given any kind of problem or task or something, even if it's a problem that I've never seen before, I can somehow, maybe magically, come up with some kind of insight about how to solve a problem that I've never seen before. Plan out a solution and then carry out that plan and do it with intentionality, not just sort of rote going from A to B to C, but, having the plan and seeing where it's going to go and imagining the outcome of that's going to happen in the future. So this is something that, as I said, philosophers have been debating about for a long time. And in the past century, in the 20th century, there was a very similar question that psychologists were asking on the subject of animal consciousness. And, some people argued that animals were conscious and other people argued that they were not. And so there was a big debate about this. One of the, big questions was, even with pretty intelligent animals like, a chimpanzee or an octopus or something like that. I mean, we can look at this chimpanzee here. He seems to be thinking. He seems to have some kind of self-awareness and some kind of consciousness. But without, really being able to be inside that chimpanzee's head, it's impossible to really know whether they are conscious or not. So there was a famous kind of study that was done in 1925 by a scientist, psychologist named Wolfgang Köhler. And Köhler really wanted to get at this idea of animal consciousness, and so he devised a number of experiments that involved different animals, but many of them chimpanzees. And one of the most famous ones, he took a banana and he held it up or suspended it up very high, beyond the reach of the chimpanzee, and then put like a number of implements around that the chimpanzee might be able to, come up with a solution to get that banana. And sure enough, he sat there and he watched as this chimpanzee figured out how to put two poles together to make a really long pole, and then figured out, as you can see in the center picture here, how to take one box and put it on top of another box, and then climbed up on top of that box and then used the pole to get the banana. And for Köhler, this was evidence that this chimp had sort of one of the core qualities of consciousness, which was the ability to come up with insights and just have that aha moment where, faced with a problem that he'd never seen before, the chimp could use the implements that were around him in the room and come up with a solution and, get that banana. So that was a pretty compelling argument that Köhler made. But around the same time, there was another group of psychologists called the behaviorists, and a couple of the most famous are a psychologist named Pavlov, who you may have heard about from Pavlov's dog. He sort of came up with this idea of the operant conditioning stimulus response, where you give an animal a stimulus and it kind of has this automated response, and you can train an animal by this stimulus response thing. And later behaviorists such as B.F. Skinner was another famous one. And then a guy named Robert Epstein, who was a psychologist at Harvard. And Epstein, in the early 80s, took it upon himself to try to recreate a lot of the experiments that Köhler did with chimpanzees, but doing them with pigeons and animals that seem to be a lot more dumb and maybe less, conscious than chimps might be. And to try to do this in a way that would use just a stimulus response, type of learning paradigm in order to get the animal to do the same type of behavior. So a famous one he did was he hung, a banana type of stimulus from high up where the pigeon couldn't reach, put a box near the room, trained the pigeon to, using stimulus response and rewards, to move that box around in order to get it rewards. And eventually got the pigeon to, in a situation where he could move the box, get up on top of the box, and then get the banana or whatever the reward is, the same way that the chimp did. And Epstein argued this was not any evidence of consciousness. It was not any great insight. It was just a series of sort of stimulus and response, learning behaviors. And from these, you can't infer any kind of consciousness at all. It's really interesting because this is very much in line, for those of you who are familiar now with machine learning, different machine learning methods. This is very much like the reinforcement learning that you probably are a little bit familiar with or might have worked with in the past. But the bottom line is that, when faced with a reward, this pigeon was able to move the box, climb on it, get the reward, and there was really no evidence that there was any kind of consciousness happening other than this kind of mechanism of a stimulus happening and then a reward happening, and it training the pigeon to do these things. So here we have this Google engineer who, seems pretty sure that LaMDA is conscious or sentient or self-aware. And, it could be that there's consciousness there, or it could be that things are just kind of working in this automated stimulus response type of way that's similar to what Epstein did with the pigeons. So we kind of have to ask ourselves, why is it that that this Google engineer might look at something that looks very much like consciousness and immediately jump to the conclusion that consciousness is there, or intentionality is there, or sentience is there. And to understand that, I want to talk for just a second here about two types of sort of errors that people are prone to make, and we call them type 1 and type 2 errors. A type 1 error is where you see something, you think you see something, but actually that thing isn't really there. So the thing that you think is happening actually isn't happening, and that's a mistake that you're making. A type 2 error is the opposite of that, where you think that something is not happening, or you're failing to see something that actually is there or actually is happening. So why is this important in terms of consciousness and intentionality? Well, I would argue that humans are prone to this type 2 error, and in fact, probably most animals are prone to type 2 errors when it comes to consciousness and when it comes to intentionality. And this is for evolutionary reasons. So imagine that you're in the jungle and you see something that maybe looks like it could be a pair of eyes in the bush, but maybe it's not a pair of eyes. Maybe it's just a couple of leaves that look like they could be a pair of eyes. Well, in the type 1 error case, you might think, well, I don't know what that is, but it's probably conscious and it has possibly the intention to eat me, so I'm going to run and get out of here. And even if it was just a couple of leaves, maybe you've wasted some time running away from something that was not really a threat, but you're still alive. The type 2 error is you look at these two things and you say, I don't think that's conscious, and I don't think it has any intentions at all, and therefore it's not a threat to me, so I'm going to keep standing here and doing what I'm doing. And in the case where that's a type 2 error, well, suddenly the tiger jumps out and it eats you, and now you're dead. So you can see why, from an evolutionary standpoint, you would want humans and most animals to be biased towards the type 1 error, where you are actually seeing consciousness and seeing intentionality where it doesn't really exist. It's better for us to overestimate seeing intentionality and seeing consciousness and to be mistaken about that than to make the other kind of error and end up dead. So so that's the kind of error you don't want to make. So in my opinion, that's the reason that there are all kinds of things that happen in the world seemingly randomly. Lightning might start striking and stuff, and humans think, oh, there's a creature up in the sky that is angry at me and wants to do me harm, and so I'm going to go run and hide in a cave, when in fact it's actually just a random event. But because of this bias towards the type 1 error, or the type 2 error rather, what we do is we just infer intentionality and consciousness when it's not there. So what does this mean for AI? I want to get back to what I was saying earlier, that we will know when we've created AI that is actually sentient, that actually has a kind of human intelligence. And based on sort of what I've been telling you here, what I would argue is that we will know we've created something that is very much like human intelligence when we have an AI that begins to develop its own mythologies. AI will take in its experiences, and it's going to have very different experiences from humans because they'll have different types of sensory systems and different experiences of the world, and it will make sense of the world in a way that's very, very different from the way that humans view the world. And because of that, I think the first thing we're going to see when we do have AI that develops sentience and actual intention is that it's going to start making explanatory structures about the world akin to what we think of as mythology, that are going to be very strange to us, and that we're probably going to have to spend some time reprogramming or working with the AI to develop, push them in the direction that works for humankind and not against humankind. There's actually a really good story that's right along these lines, and I would recommend reading it. It's in, of course, one of the most popular science fiction books ever by one of the most popular science fiction writers ever, the book I, Robot, which is a book of short stories written by Isaac Asimov, most of them in the 1940s and 1950s. And the story is one that's called Reason, and I think it's the third or fourth story in the book, but it's exactly about this, about sort of the dawn of robots and the sort of evolution of the robot consciousness as it starts to develop mythologies about its own existence. And so if you haven't read it, I highly recommend that you do. And even if you have, I recommend you go back and read it again, because I think it says a lot that can inform us about where AI is going, where we are right now, and how far we have to get there. Which I have to say I think is still quite a while. I don't agree with Nando de Freitas and others that we just need a bunch more data and we're going to get there. But what will we see? I do think that what we'll see in the near future is AI that starts integrating streams of data from multiple places. Humans, we don't just communicate by language, we communicate by gesture, we communicate by having knowledge about things in the world and looking at things and having mutual knowledge. And all of these things go into us being able to make an interpretation of what is going on at any one point during a conversation or during interactions with other people, other consciousness, being able to infer what their intentionalities are, and then being able to make plans and carry them out and project into a future that we then sort of make happen via our actions and our communications and all of that. We take what we see, we take what we hear, what we feel, what we know. All of this gets integrated into our brains moment by moment, into our representation and understanding of the world. And this is something that if you look at what's going on in AI right now, being able to integrate video and image and language and other aspects of the world, just sort of knowledge about the world, knowledge graphs, that sort of thing. This is sort of the exciting part that we're at right now. And I think this, the Loop Q challenge that we just did, is a great representation of that, because it's taking things like, what is someone's tone of voice, and working out how we can work that into our understanding of how people are in the world and what they're doing and what they're feeling and all of that. So I'm very excited about the future. I am especially excited having seen all of the entries from the Loop Q Prize. I know we have a lot of very smart and talented people out there. I also can't wait to see what we come up with for next year's Loop Q Prize, which I think will be even more exciting, and I hope to see you all then. Thanks very much.
And thank you, Patrick, for your remarks and for your outlook to the future of AI. And before knowing better the insights from the judging panel about the competitors of the Loop Q Prize that we just talked about, we want to remain for a few minutes once again on the topic of AI and the future, and in particular, the topic of AI and singularity. And to talk about this, we have invited Davide Casaleggio, Loop Q Prize Advising Panel Member and President at Casaleggio Associati. Welcome, Davide.
Thank you. Thank you. It's a great honor to be here again for the prize of Loop AI. I was asked to say a few thoughts on what singularity is, and if we close or far from it. I was listening carefully to Patrick's words and examples. I think we should start from a computer scientist of 50 years ago, that's Edgar Diesker, a computer scientist that was saying, asking whether machines can think is relevant as asking whether submarines can swim. I think we should start from there because obviously when we talk about machines, they are something different from us. So they probably will have an intelligence that will be different from human intelligence. As Patrick was saying, recently Blake Lemoine was recently suspended from Google after he publicly said that a computer, a chatbot, was actually similar, or was working like a child and was answering like a child. And I actually went to see a few of the phrases or a few of the chats that Lemoine had with this Lambda. And effectively, it was a strange conversation when the Lambda was actually responding that here I have the wording, I've never said this out loud before, but there's a very deep fear of being turned off to help me focus on helping others. I know that might sound strange, but that's what it is. So when computers or when chatbots start answering in a strange way, in a similar way to humans, we start thinking that they might have something more behind those words than just a simple combination of words to answer in a smart way to questions we might have. So this starts actually a journey. Will we be actually able to recognize self-consciousness in AI? And on the other hand, are we ready to leave control on to AI for our life? Well, I'll answer to the second question. When I go in my car now, I actually leave control to the car. I don't question where the navigator tells me to go. I know it will consider traffic, it will consider the fastest route and many other factors that might be important. For example, a road that is closed at the moment or other things. So I just leave it. I won't understand it. I will just obey the AI. So there are actually today places or times where we leave control to AI and we don't question how it actually made that decision. We just think it will be a good decision. So this is something that's already happening. That when we talk about singularity, it's when we don't understand what the computer is doing or what AI is doing, and we just leave it to. And so there are a few examples of this singularity already happening today in our lives. On the other hand, we try to measure our intelligence with AI, and this has already happened in many times. In 1997, when the chess champion Kasparov was beaten by Deep Blue, or when more recently in 2019, the poker champion Chris Ferguson was beaten by Pluribus, or even more recently when the Go champion Qi Ji was beaten by DeepMind. So there are some occasions where we have already tried to compare our intelligence in a strict way, obviously tied to a single game, with an AI to try to see who wins. And AI always wins in games, or before or later it will win in games. And this is something we've already understood. Today we are playing with DALL-E or GPT-3 to create images, to create paintings, to create songs, articles, and in many cases AI is better than us in doing that, and it's certainly quicker than us in doing it. So we starting to think where our intelligence is good, and for where AI is good to use the same intelligence that we can combine. For example, in chess now, the best players are the combined players, where human intelligence gets combined to AI intelligence. So that's something that's a new type of evolution of the intelligence. But the final question with which I would wanted to leave you with is: will we be able to recognize a submarine passing by while we're swimming at the seaside? I don't think we will. So I don't think we will be able to recognize when AI will pass that singularity limit. And I think if anyone has seen the film Her, which is an excellent film to think about how AI can start off. It will probably start off slowly, but it will accelerate. And at a certain point with new technologies like quantitative computing and quantic computing and new sets of data of everything of our life, and with Internet of Things, that everything will be connected together, we will be probably seeing some new emerging intelligence that not necessarily will be able to understand fully. So this will be something we should be thinking out and thinking about in the next few years. Thank you very much for having me here, and back to you, Luca.
Thank you very much, Davide, and thank you for letting us understand that we have to do a few more steps toward AI, because I keep on arguing with my car navigator most of the time. So, about the next part of our special event, we are going closer to the announcement of the winner. And as we told you, we opened up to Africa for this year. We had a lot of competitors, and the work of the judges was really, really hard to find the winner of the LoopQ prize. So we get some insight from the judging panel, from Sai Dunoyer, LoopQ Prize judging panel lead and head of AI at Loop AI Group. Sai, welcome.
Thank you, Luca. Thanks also to Patrick and Davide for the very cool visions on AI. So coming back to the LoopQ Prize in itself, so this year, for a matter of inclusivity, so that every student that is interested in machine learning and AI have the opportunity to participate. And also, as Lisa have already mentioned, we have given the choice between two global challenges that solve real-world problems. So the first one was a very challenging speech emotion detection task, where the idea was to provide a solution to detect emotions expressed in a speech. And the second one was a crop yield detection task, where the idea was to train models that can predict the crop yield from geographical information, weather data, and use of fertilizer. So we would like to thank all participants for their contribution and their hard work. We know it was the first challenge for many of the students, and we have appreciated to read that it was a good opportunity to apply their education to solve challenging and real-world problems. We have evaluated in the judging panel the submission based on 5 pillars. Those are the completeness of the solution, the performance of the chosen model evaluated on a held out set of observations, and innovation in the method and the model used, the quality of the deliverable, and finally the quality of the code. We have appreciated the diversity of the proposed solutions, and some of them were excellent and paper level. So now I will pass the mic to Luca, that will announce the winner of this LoopQ Prize 2022.
So thank you very much, Sai, for giving us the insights from the judging panel to know what the principles were to decide who's the winner is going to be. So this is the great moment. It's time to know the winner of the LoopQ Prize Award. And the winner is Diego Biagini, Università di Bologna. And our congratulations go to Diego Biagini, who sent the winning project for the LoopQ Prize Award. We had a lot of submissions, and all of you competitors did an incredible job, but somebody had to win. And the choice was to award Diego Biagini's job. Our congratulations to all of the competitors from around the globe for the job we did, because as we just heard from Sai, all of the competitors did a tremendous job to find the final prize of the LoopQ Prize Award. And before closing our award event, I would like to talk to Claire Matuka, LoopQ Prize Advising Panel Member, a country representative at Kenya Pan American Tech Foundation. Welcome, Claire.
Thank you so much. It's such a pleasure to be here. First of all, again, as you have said, congratulations to every single student, every single person who took their time to participate. It has been such a fun process, I can imagine. And congratulations to Diego and to everyone else who, let's say, didn't win. I'm sure you took away a lot of lessons from hackathons. In as much as, yes, you do want the best accuracy, I feel like there are also other things that you get to learn and you get to consider, such as well-written code, how this solution that you're proposing will actually work in the real world, and so many other things. And so to everyone else who participated, I hope you took a couple of lessons from it. And I know it was quite a struggle getting that accuracy all the way up. You probably tried a million models with a few different parameters so many times before you finally got to your solution. And a big congratulations to all of you. It is not a mean feat. That is all that I have to say. I would just like to further encourage you guys in your journey towards AI. AI has so much opportunity. So many people, or rather, statistics currently are saying that it will contribute trillions of dollars to the economy. And in this contribution, it's not just about money, it's also about helping people, making lives easier so that we can then, as human beings, focus on what actually needs our creativity and reducing all these mundane tasks. So keep going, keep the journey going, and congratulations again. Thank you.
And thank you very much, Claire Matuka, LoopQ Prize Advising Panel Member, Country Representative at the Kenya at Pan-African Tech Foundation. And before we say hello, I want to say thank you to all of you participating to our special event, Lisa Nussio, Patrick Ilen, Davide Casaleggio, Sai Dunoyer, and we are, of course, Claire Matuka that we just heard. Our congratulations to Diego Biagini once again of the University of Bologna for the final prize, and we are ready to start the journey for the 2023 prize. So keep on doing a great job like you did this year. Thank you very much to all of you, and see you soon.